RT1-2 is about calculating slope of line and classifying types of slope. You should remember a lot of this from algebra, but some of it may be new to you or may be things that you forgot. So slope is really about how steeply a line is rising or falling on a graph. We can think of that as, there's a line. If I have a greater slope, I might have a line that's more steep. If I have a slope that's not as great, it'll be less steep. Some different ways that we talk about slope are rise over run, change in y over change in x, delta y. That triangle symbol is really the Greek letter delta, and it stands for change, over delta x. And then we have our formula, which is y2 minus y1 over x2 minus x1. Better y's up, get your y's up is one way that kids in the past have remembered that their y's go on top. You want to make sure that you're lining your points up. So if I have point AB and CD, I want to make sure that I'm doing B minus D over A minus C, because BA came from the same ordered pair, C and D came from the same ordered pair. All right, so if x1, y1, and x2, y2 are the coordinates of the endpoints of a segment, then the slope, I clearly didn't edit my slides before I made this, sorry, is going to be y2 minus y1 over x2 minus x1. I want to make sure that I actually subtract those numbers and simplify, and we'll do some examples there. This is a formula that you will want to memorize for your test. There is a link to Slope Dude, which most of you are familiar with if you took 6th grade math here. If you didn't, welcome. You are going to get some insight into Minnetonka math culture today. There's a link to the video on Schoology. Go ahead, pause, watch it. Take it home, watch it for movie night. It's a classic. There's also a song to Flow Rida's Low. I'm not going to sing it right now because I have a little bit of shame, but I don't have that much shame. So when I'm back, we will sing it together, along with a few other songs in this unit. All right, we're going to do some examples together. So we're going to find the slope of a line that passes through -2, 1, and 3, 7. First, I'm taking the difference of my y's. So I have 7 minus 1. Then the difference of my x's. 3 minus a -2 becomes a +2. And now I'm just cleaning everything up. So I have 7 minus 1 is 6. 3 plus 2 is 5. I can't reduce that fraction. That's my slope. Right, now I'm asked to find the slope between 3.55 and -1.68. Same thing, I'm taking my y's. 8 minus 5 over my x's. -1.6 minus 3.5. And I get 3 over -5.1. We don't really like to have decimals in denominators or in fractions at all, really. So I have a choice here. I can either write this as 30 out of 51, just move that over, and then move my negative up top because we like our negative to be either out front or in the numerator. I don't know why mathematicians just decided that looked classy. Or I can write it as a decimal. So I can literally type into my calculator -3 divided by 5.1, and I get kind of a gross decimal. So in this case, I would stick with this fraction. If I got a nicer decimal, then I might write out the decimal. But with this one, I would have to round, so we're just going to go with the gross fraction, and it's going to be okay. All right, on this last one, I'm asked, I'm given a point, -4, -2, and positive 4y, and I have a slope of 1/2. I'm trying to find y. I'm going to start with my equation. So I have y minus a -2 becomes a +2 over 4 minus a -4 becomes a +4. I'm going to clean this up a little bit before I set it equal, or actually I'm going to set it equal to my slope. Now I'm going to clean it up in my next line. So I have y plus 2 over 8 equals 1 over 2. I have a proportion. You did learn about these last year, but you might be rusty. I can cross multiply here and set them equal. So I can set up an equation that says, hey, 8 equals 2 times y plus 2. And then when I'm doing some algebra, I get 4 equals y plus 2 because I'm dividing by 2. Subtract the 2, and I have y equals 2. If I want to check this, I'm going to go back, and I'm going to say, hey, if I put 2 in way up here, 2 plus 2 is 4. 4 over 8 does indeed reduce to 1/2. I know I did it correctly. All right, we're going to do a similar problem now. This time I have y plus 4, because I'm subtracting the -4, over 8 minus -8, or plus 8. That needs to reduce to equal 3 over 4. Clean it up a little bit in my next line. So I get y plus 4 over 16 equals 3 over 4. And now I'm going to cross multiply. So I'm doing 16 times 3, y plus 4 times 4. And I'm left with 48 equals 4 times y plus 4. When I divide by 4, I have 12 equals y plus 4. So y equals 8. All right, on this last one, I'm asked, is y equals 2x minus 4.9 a bisector of the line segment with these endpoints? Okay. If it's a bisector, it needs to go through the midpoint. So I'm going to add my two x's. So I have -1.8 plus 8.2 divided by 2. Add my two y's, 3.9 minus 1.1 over 2. Clean that up to find the midpoint. -1.8 plus 8.2 is 6.4 divided by 2. My midpoint is at 3.2 for my x coordinate. 3.9 minus 1.1 divided by 2, I'm at 1.4. The question now is, does this point lie on this line? The way I check is by plugging my x value in and seeing, gee, do I get that y value out? So I need to know, does 1.4 equal 2 times 3.2 minus 4.9? So 1.4 might equal 6.4 minus 4.9. 6.4 minus 4.9 is 1.5. 1.4 does not equal 1.5, so my answer is no. It is not a bisector. It does not cut through the exact center of that line segment.